So I told Amanda I'd introduce myself because it's been here a while now, so everyone's probably come into contact with me in some shape or form. So I'm going to present today on one of my kind of great interests, which is executive functioning in young children. Most of my research projects are with children 6 and under. Some of them are with typically developing populations in terms of developing new assessments and looking at the influence of environmental factors on executive development. And then other projects are focusing more specifically on patient populations and trying to kind of, I suppose, establish early predictors of executive dysfunction. And I'll explain why executive functioning is something that I kind of constantly try and preach and convert people in terms of thinking about it when they're working with children, but also when they're looking at other factors, because it really kind of feeds into a lot of everyday domains. So first of all, for those who haven't kind of come into contact with the term before, executive functioning is often described by textbooks as the air traffic control system of the brain. So it's that cognitive skill that kind of pulls together loads of different, more basic cognitive skills and helps us regulate our behaviour, control ourselves in social situations, and work towards kind of long-term goals. So in terms of basic executive skills, you can think about them as being things like attention control or impulse control in young children, and then complex executive functioning skills that build upon those in adults are things like problem-solving skills, decision-making, and working memory. So executive functioning is typically associated with the prefrontal cortex, which is in the frontal lobe. And of course, the frontal lobe is about a third of the human cortex. So we do a lot of complex thinking, and we do a lot of social thinking, emotional thinking, as well as kind of abstract reasoning and so on. So we do a lot of, we use our executive skills quite a bit. But of course, the prefrontal cortex doesn't work in isolation. It's quite interlinked with lots of other brain areas, which is what makes it difficult when it comes to kind of neuroimaging studies in terms of trying to find the precise correlates or the precise regions that link in with specific types of executive skills. I really like Anderson's developmental model of executive functioning because it really kind of encapsulates the overall idea of what executive functioning is, but it breaks it down into different domains. This field has really kind of seen a lot of leaps and bounds in the last 20 years or so, but any kind of delays in its development and in its advancement are often due to kind of arguments about what is executive functioning, what's the difference between the different domains, how do we group them, how do we cluster them, and there's a lot of debate around this and how you define maybe cool executive functioning, which is where you're doing maybe an inhibitory control task in a controlled environment, versus hot executive functioning, where you have to stop yourself from blurting out something mean when you really want to hurt someone's feelings. So how do we group those together and tear them apart? So in terms of developmental research, Anderson has described the development of executive functioning really nicely. And he has this 4-factor theory, and in his theory the domain of attention control emerges first. So this is kind of the foundation of all our other executive skills, and within this domain you've got real basic skills like inhibition, selective attention, self-monitoring, and from this domain we develop our other domains, which are grouped into cognitive flexibility, goal setting, and information processing. So within each of these domains, you've got more complex things like conceptual transfer, feedback utilization, planning, conceptual reasoning, and so on. So between all of these other domains, you've got these bi-directional relations and bidirectional influences. So if you have a difficulty in one domain, you're likely to have difficulties in these other domains. Whereas attention control has this unidirectional influence on these 3 other domains. So if you've got poor attention control emerging first, then these later emerging skills are going to be impacted as a result. And it's often why, you often hear of executive difficulties in neurodevelopmental populations like ADHD and ASD, and theoretically you can kind of bring this back to conceptualizing it from the perspective of attention control skills emerging first. So just a little bit about kind of what's happening on a brain-based level. So we've got lots of structural changes. The frontal cortex, the prefrontal cortex, is the slowest cognitive kind of area to develop, or language skills or visual processing skills, all of these emerge and mature at much earlier stages, whereas our prefrontal cortex is still undergoing a lot of reorganization in terms of new connections and pruning away connections and grey matter density, right up until late adolescence and the early 20s. And you do see kind of around that adolescent period that there's a little bit of a disconnect where you've still got this kind of slow development of the prefrontal cortex, which is kind of coming along and helping them make decisions in terms of taking risks and so on. And suddenly the limbic system, which controls their emotional processing, has all of these changes occur due to hormones and so on, which is why adolescence is often seen as a real kind of risky period of development. From an ERP perspective, we also see lots of changes on a functional level. So the neurophysiological correlates of executive skills and lab-based tasks, and these show developmental changes right up until adulthood again. These changes are seen in lots of different ways, and I'll go into those a little bit more in the next section. But first of all, I just want to kind of, I suppose, send a message home in terms of why we should be looking at executive functioning in young children, and why it's really important kind of omnipresent skill that children should be promoted in classroom contexts and from very early on in home environments. So we know already that there's a protracted development of the frontal cortex, but also more and more research is emerging to show that executive skills are more predictive of school readiness than IQ, than reading or maths ability in young children. And executive impairments are associated with most forms of psychopathology, poor social skills, poor quality of life, and poor academic attainment. So really having executive dysfunction means that you're not set up to meet some of these other goals in life, in social contexts, in academic contexts, and so on. So because of the protracted period of the prefrontal cortex, it means that executive functioning skills are susceptible to disease, but also they're susceptible to poor environmental factors. So low socioeconomic status is a risk factor for poor executive skills, and so on. But in the same way that there's this period of vulnerability, there's also an opportunity for growth. So there's the opportunity to actually promote these skills earlier on in young children, in order to promote these skills at a very early stage, when they're still emerging, we have to kind of establish ways to identify these deficits and to come up with interventions that can actually have an impact. So one of the barriers in research over the last few decades with children under 6 in the domain of executive functioning is that there's just been a complete lack of normed or standardised assessments. So we've got loads of executive batteries that we're very familiar with, and there's executive components in, say, the NEPC, the DCEPs, and so on. But a lot of these measures only really are standardised from about 6 years of age. So this is due to a number of reasons. One of the reasons is that in the past people said you just couldn't measure these skills in children younger than 6 years of age. And also, for anyone who wants to actually try and norm a task or develop a task, it just means that you need a lot more people because there's a lot more variability and a lot more change happening in this period. So one of the kind of goals of my research was to develop new ways of tapping into executive skills in young children, and I've done this through various ways, so using ERP tasks, eye tracking tasks, as well as computerized assessment and tabletop assessment that look at specific skills like maybe selective attention or working memory. So next I'm going to talk a little bit about an ERP study that I did, and this ERP study was specifically looking at attention control because that is that first domain that emerges in young children, and we know from previous ERP evidence that by 4 months infants show the ability to actually distinguish or selectively attend to a novel stimulus versus a familiar stimulus. And by 6 months, they can distinguish between a frequent stimulus and a non-frequent stimulus. And we know this by looking at their ERP peaks when we analyse the data. And we've established this by using a paradigm called the oddball paradigm. So frequent versus infrequent is a baby is sitting there passively and you're playing ba, 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 bo, ba, ba, constantly, hundreds of times, and trying to see if they actually are paying attention to the novel or the frequent stimulus, or the infrequent stimulus. You can tell the difference. So Hilliard identified the ERP index of selective auditory attention in adults, and now I'm kind of moving from the oddball task to a more kind of ecological attention task. So one that kind of, I suppose, represents an everyday context. And I'll explain that a bit better in a moment. But first of all, typically adults show an early positivity followed by a negative component at about 100 milliseconds after a stimulus is presented in these kind of binaural auditory tasks. So here in this diagram, you can see that we've got 2 lines on each of these ERP diagrams. One line is for the attended stimulus, so the side that they're supposed to be listening to, and the other line is for the unattended stimulus. Now, what makes this task a little bit more ecological is that they have to listen to either their left side or the right side, and it often changes from one side to the next. And while they're doing this, they're in a crowded auditory environment. So there's one story happening in one ear, another story happening in another, and they have to follow the narrative in one side and actually block out the story from the other side. And throughout the story, there's being beeps or bursts of white noise kind of interjected in the auditory stream. And if they're able to, so you can see here for the adults and the children, if they're able to distinguish or pay more attention control to the side that they're supposed to be listening to, you're going to see this difference in terms of the peak that you get between both conditions. But what you'll notice here is that for adults, we've got this kind of really quick P1, N1, P1 response, and P stands for positivity, N for negativity. Whereas for the children, we've got this totally different response to a very similar experimental setup, and this is just a broad positive peak that lasts for about 200 milliseconds. So the shape, the design, everything's different, and that's kind of described as morphology in the ERP literature in terms of what the peak actually looks like or what the response looks like. So in this diagram here, you can see that at the top we've got 3 to 5-year-olds, and the participants are getting older and older and older until we've got the adults here, and you can see that the ERP response is becoming more and more kind of defined as the participants get older. So we're seeing kind of changes in morphology, so the shape, what the actual peak looks like in response to the experimental stimuli, the amplitude, so how big the amplitude is, the peak response, the latency, which is kind of the speed at which the peak occurs, the polarity, whether it's positive or negative, and the topography, so where these actual kind of neurophysiological differences are actually being picked up on the brain. So the topography changes because as we get older, we become more specialized, we're pulling on less general areas. So these changes occur due to lots of developmental changes that are happening on the brain-based level. So harking back to those figures where we showed all the myelination, the synaptogenesis, specialization, pruning, and so on. All of these developmental processes are actually contributing to the actual differences that we're seeing on the ERPs that we get out of the experiment. And then there's other kind of effects that we need to think about. So there's genetic factors, there's environmental factors, so things like socioeconomic status, there's task or design and demands. So for example, if we were thinking about an oddball paradigm where 2 participants were doing the same experiment except one of them was just listening to the changes and you were looking at the ERP responses, and the other participant had to press a button every time they heard the novel noise, then the actual kind of ERPs that you would get from those experiments would be different, because as well as the actual selective attention differences that the ERPs are demonstrating, they're also showing other things, so the participant getting ready to press the button and these other kind of neurophysiological effort that they have to use in this task is pulling on different demands, so you're seeing different responses. Stimulus properties, so if a stimulus is more novel, then it's probably going to elicit a larger ERP than one that's less different to the frequent stimulus. And also there's always individual differences in terms of task efficiency and so on. So the particular response that I'm interested in is the early frontal positivity. So this broad ERP peak that you see in young children in an attention control task when they're listening to noises in a crowded environment. And in preschool children, you see this peak lasts for about 200 milliseconds, whereas by 6 to 8 years old, already they're able to kind of show the same neurophysiological processing in half the time. And this is because of developmental gains in processing speed as well as attention control. So there's lots of changes happening from an executive perspective. Some other studies have shown that different populations have shown differences in terms of this response that is elicited. And the nice element of using an ERP experiment rather than a behavioural task, or as well as behavioural task, is that, okay, we're looking at attention control. We want to see sometimes if there's differences between the patients versus the controls, but also in this attention control task, there's two conditions. So we can see, is it that they're worse at actually just pushing out the distracting information, or is it that they're worse at allocating enough neural resources to the to be attended information? So in one study with children from lower SES backgrounds, they found that the difficulty here lay in a reduced ability to filter the irrelevant information, whereas in a cohort with specific language impairment, the difficulty lay in a reduced amplification of the neural response to probes in the attended channel, rather than distractor suppression. And with this particular paradigm as well, there's been some attempts to actually validate what we're seeing on an ERP level with behavioural ratings. So the brief is a well-known executive parent report scale, and some research has shown that there has been kind of a relation between what we're seeing in the lab on the ERPs and what parents are reporting. But these correlations between behavioural tasks and ERPs are really hard to actually obtain significant and strong in terms of really convincing relations, because on a behavioural level you're capturing multiple levels of behaviour, whereas in an ERP task you're looking at very specific components. So what's interesting is that there's been some intervention studies that have actually shown that after intervention in preschool children, or in the US in kindergarten children, they can actually see differences on a neurophysiological level when they've introduced interventions for executive functioning into the school environment. And this particular study from Novell and colleagues is really interesting, because they had children who were starting in Head Start, which is the really popular kind of scheme now that's rolled out in preschools in the US. And then they had one intervention, which was the ABC intervention, so the children got more support in terms of executive promotion and executive development. And then they had this other intervention arm, which was the actual ABC intervention combined with a parent intervention. So the parents were also getting kind of support in terms of scaffolding skills, communication skills, and so on in the home environment. And what they found was that after this period of time, the most significant gains, or the only significant gains for a more typical ERP response, was seen in the children who obtained both the school-based intervention, or the preschool-based intervention, and the home-based intervention. And that makes sense from the perspective that 3-year-olds, 4-year-olds, 5-year-olds, they spend most of their time at home, in the home context. So if they're getting an hour a day and then going home to an environment where they can't build on that, then it's not having as much of an impact. So we want to take this experiment and implement it with children, preschool children with sickle cell anemia. And the reason that I was motivated to work with this group is because there's a lot of literature with older children who have sickle cell anemia to show that executive dysfunction is prevalent. And I'll go into the reasons why it's prevalent in older children in a moment, but until these studies that kind of came out of this project, there was no research that actually looked at children under 6 years of age. So we had no kind of idea about, are there differences at this stage of development? And there were no studies across any kind of age range that used ERP or neurophysiological approaches. So we didn't know if there was any differences on a brain-based level at all. So this is just a visualization of what the paradigm actually looks like. So the child is sitting here, they've got two auditory streams, and the probes or the bursts of white noise are being put into these streams. The paradigm is adapted to actually help a young child sit through this experiment. So they have a visual stimulus that sits on screen that actually matches the story they're supposed to be attending to. There's an arrow on screen that points to the ear that they're supposed to be attending to. They have to do a training session. It has to be a female versus a male voice to help them with the auditory discrimination. So they need a lot more support to do the same task as adults do. And even down to the lengths of having to get them to hold Teddy and get Teddy Bear to do the task, just so that they're not moving around and playing with the nets and making really noisy data. So this is the study that came out of this, and what we found was that there were differences on a neurophysiological level, and I'll show you where we found those differences in a moment. But first of all, just in case you're not as familiar with it, sickle cell anemia is a hereditary red blood cell disorder, and what happens is that the hemoglobin in our red blood cells, which carries oxygen all over our body, isn't working as efficiently. So the red blood cells are breaking down a lot faster, but they're also just not carrying oxygen as good. So as well as having issues with the brain, there's multi-organ difficulties in this patient population, and up to a third of children actually experience stroke by the time they reach late adolescence. Now that incidence is coming down, and as well as clinical stroke, you have silent stroke, which is seen as kind of white matter flecks on the MRI scans. But even the children, the school-age children who haven't had stroke or silent stroke, still have executive dysfunction. And kind of the theory around this is that even if they haven't experienced stroke, they still experience this chronic hypoxia or low level of oxygen to the frontal cortex, which has this really, really protracted period of development. So their executive skills are impacted. And also by school age, they're experiencing a lot of pain, so they're missing out on more school, which is contributing to the potential differences at that stage in development. The disease has progressed. So we were quite interested to look at the preschool age children to see if we were seeing any differences at this stage in development. Because the interesting thing about sickle cell anemia is that children don't actually experience any symptoms till typically about 5 or 6 months, because they've got their fetal hemoglobin, which is actually protecting them. So the sickle hemoglobin only comes into play in the second half of their first year. And they haven't started school yet at this stage, so they're not really missing out on much school. So we don't know if it's just a difference later on in life of experiencing the silent infarct, of missing out on school, and also the impact of a double disadvantage in a lot of these cases, because sickle cell anemia in Ireland, in the UK, where this particular study is done, a lot of those families are immigrant families, so they're at a disadvantage because of the sickle cell anemia when it comes to executive dysfunction, but also the poorer SES, which we know is associated with executive dysfunction. So what we found in the preschool cohort is that here we can see in the typically developing children, and these typically developing children are matched for socioeconomic factors, matched for IQ, age, gender, and so on, and we're seeing what we expected to see. They're showing this peak at about 100 milliseconds, and it lasts for about 200 milliseconds, and we're seeing a similar peak in the ignore condition, but not to the same extent because they're successfully inhibiting or blocking out those stimuli. Whereas in the patient condition, we just weren't seeing this response. And even when we looked at individual data sets, we were seeing really messy data. We were trying to kind of play around and see, well, what exactly is happening here? And when we ran the data analysis, we found that actually the differences lay in the neural allocation of resources in the selective attention conditions. So these children were more variable, but they just weren't placing as much attention to the attended conditions. So we weren't actually seeing differences on a behavioural level. And after each trial, we were getting them to answer questions about what was that story, you know. It wasn't things like Humpty Dumpty because they've heard these stories before, but the questions would be similar, like, you know, what happened to Humpty Dumpty in the story? And that was kind of a good indicator of whether they were listening to the right story or not, so we knew which trials to exclude. And you can see here as well that these are the patients on top and the controls at the bottom. And we've got the attended and the ignore condition here and here. And this here is the actual difference between the two conditions. So we're seeing a lot more happening in the control children in comparison to patients. So as useful as ERP studies can be, I really feel strongly about using more ecological assessment of executive functioning, particularly at this stage in development. And the reason for this is that it's very important to have tests that tap into specific domains. So you can get a child to come in and get them to do a processing speed task, and then get them to do an attention task, and then a working memory task, and then a shifting task, and so on. And they might do good in some tasks and poor in the other. But in terms of that form that you're giving back to teacher, that you're giving back to the parent, it's not exactly reflecting how they're doing in everyday contexts, because these tasks in a lab environment, they're initiated by the examiner saying go and stop, and they're timed, and they're just doing one thing in each task. So if the difficulty is that they are actually okay with paying attention in a very quiet environment, but not in a noisy classroom context, then that's not really captured. And the information that these assessments relay back to teacher can also be very difficult to actually integrate into reasonable adjustments in the classroom environment. So I strongly feel that ecological assessment should be used in conjunction with these kind of lab-based and parent report approaches. Understanding the type and the level of support required to complete the tasks in an everyday context is integral to promoting the development of children with cognitive deficits. So knowing exactly what type of support they need as well as what level of support they need is really important. And this is just an example of children using executive functioning when taking turns in the yard. So if they're playing a ball game where they have to pass the ball around, when might they need working memory?
What's next?
Yeah, to remember whose turn it is to throw the ball to. Inhibitory control.
Not throw it to the wrong person.
Yeah, not throw it to the wrong person. A 3-year-old, not just take it and run away or throw it at someone. Cognitive flexibility, when might they need that skill?
Change that maybe to throw to the next person rather than just the teacher.
Yeah, absolutely. So rules change now. Now we're moving on to a new game, and the kid has to keep up. And you often see, if anyone who watches Secret Life of 4-year-olds and all of those TV programs, that the kids who are really kind of who are delayed in these executive domains find it really difficult to make friends and to get on in that kind of playground environment. And often you see boys finding it a little bit harder than girls at that earlier stage. And that's to do with language and executive dysfunction, not dysfunction, but a slow, subtle kind of delay in comparison to girls. So you'll see sometimes when a little boy and a little girl are having an argument, sometimes the girl can be a lot more kind of vocal and she can express what she wants to say, whereas a 3-year-old boy might find it a little bit more difficult. So it kind of has an influence on how they're getting on in the playground as well as in the classroom environment. So at this stage of development, they're still in preschool, they are being handheld. So they're told, okay, you're coming here now, okay, I'm bringing you to the toilet now, okay, you're having a snack now. And they don't need to think about or organise or plan or memorise anything because their teacher is being their frontal cortex, their mom is being their frontal cortex, and their older sibling is being their frontal cortex. But as a child develops and goes through primary school and gets to secondary school, now they need to remember their homework, they need to remember what classroom they're in, they get to university and now they need to remember to pay their bills, they need to remember that they're starting work at 6 and they have an assignment due tomorrow. So that executive kind of weight gets more and more, and if you have difficulties in any of those domains, they become more obvious at that stage. So this is one of the tasks that we developed that tried to kind of bridge that gap that existed in younger children for a lack of executive measures. And this was really a downward extension of a task that was developed for school-age children, so 8 to 12-year-old children. And what the child has to do is essentially make a picture of a caterpillar by following a picture recipe book step by step. So there's a pre-task questionnaire, post-task questionnaire. Each child is introduced to the task in the same way, and throughout the task, the examiner is letting them initiate themselves and is not actually interrupting or guiding or supporting until they're struggling with a step. Within the task as well, there's specific components like using sand timers. So some kids are familiar with this because they use it when brushing their teeth. You turn it over and you have to wait 1 minute for the glue to dry or whatever. And some aren't. So we introduce all of the materials to the children before they start the task, so everyone's on a novel playing field. And also, this is not a task that you'd use to assess a child again a month later, because it's important that the task is novel. They actually need to pull on those executive skills and pull on their prefrontal cortex to achieve the outcome. So this is just kind of an illustration of what they see. So they see the page with the grass on it, and they see a photo of what you're supposed to do, and then they see an example of what they're supposed to do. So from seeing this, they're meant to work out that the ingredient box is there, everything they need is in it. Now they need to kind of actually pick out the green circle on a piece of paper and use the glue to stick it on the piece of paper. And the examiner doesn't interject until they actually start to struggle. So if the child, for example, with initiation, which is the first step, is just sitting there after the examiner says you can start, then the examiner waits for 10 seconds, and after 10 seconds offers the child a general verbal cue. So this general verbal cue might be something like, what does the recipe book say you need? What do you think you need to do first? So it's an open-ended kind of question. If the child is still struggling after 10 seconds, the examiner moves up to a gestural cue, so maybe points at the ingredient box, points at the recipe book. If the child is still struggling, they might move up to the next level, which is a direct verbal cue. You need to take this out first and put it here. If they're still struggling for that step, you might move up to physical assistance, where you're actually helping them do that step. And if they're still struggling, you do it completely for them. And then you start at the start of those levels again for the next stage of the task. And the value of that is that at the end of the task, you don't have an indicator of how long it took them to do the task. So for some children, it's 5 minutes. For some children, it's 25 minutes. It's not time limited, so it can go on for as long as it needs to be. As well as that, you have the amount of cues you've given them. So how many times you actually have to give them support throughout the task. For some children, this might be 4 or 5. For some, it might be 50 plus. And also, all these cues are weighted. So you know, are these children actually just having issues with sequencing, so moving from one step to the next, they just need a general push at each stage? Or is it that they're actually getting onto the higher levels again and again and again? And the higher levels are weighted so that you get the number of cues at the end, but you also get a total score. There's subdomains as well, both qualitative and quantitative, so the examiner can score the child qualitatively on things like organisation, emotional mobility, things that are hard to capture from a quantitative perspective. And then they're scored on things like inhibitory control, from how many times they have to be cued to wait for the sound to fall down, and so on. So the task doesn't rely on pass-fail or summary scores or time limit. they don't get penalised for motor difficulties or language difficulties. So 3-year-olds, their language and their fine motor skills are still developing at that stage. So they're not going to get penalised if they can't open the stick of glue or if they can't hold the plastic scissors. And the task is very visual. So with the older children, they actually have to follow a written recipe task to make a Play-Doh recipe. So they need to be able to read in order to do that task. So there's a structured cueing and scoring system that tries to make the task as objective as possible. And we've normed and validated the task with 166 typically developing children, and also more recently with 130 Irish children. And also we're starting to work with the task in patient population. So we've done a study with sickle cell anemia, there's an ongoing one with preterm infants, and some other centres have started to implement the measure as well. So from our London cohort, our main findings were in terms of the task utility and norms, and actually establishing whether it's a useful tool for teachers. So our main findings were that the performance on the task improves with age, performance is related to language ability, so verbal IQ. The total score on the task was related to teacher reports on the brief preschool, which is really up until maybe 5-10 years ago, the only available measure for children was parent or teacher report at that age. Interesting kind of ancillary findings were things like self-talk resulted in improved performance for children, particularly in the 3-year-olds, which was interesting from, I suppose, developmental perspective, that self-talk is them, using maybe the scaffolding that the parent uses at home or the older sibling uses at home to get through a multi-step task like baking a cake. Now I'm doing this and now I'm doing that. Whereas by 4 and 5 it wasn't having as much of an influence, because you'd expect them anyways to have internalised that inner voice. Poor performance was observed in children from lower socioeconomic areas in London, which is expected, and girls are performing only a bit better than boys, which is what's expected in the literature at that very early stage in development. We also found relations between their performance on the task and effortful control on Rothbard's temperament measure, relations between the performance on this task and an NIH toolbox executive component, which are new. It's just a very new, validated iPad. It's now iPad based, but I was using it in the piloting phase where it was computer desktop based. But it captures executive functioning. It was funded by the NIH, so it's a massive measure that's validated from 3 years up to 90, and looks at lots of other cognitive domains as well. So it's really useful in large scale studies. And already we're seeing in the sickle cell children that observable performance is seen in domains such as task completion and initiation, which was in line with what older children were shown on the older version of the task. So the task is starting to be used in clinical and research contexts in different hospitals and universities, and hopefully we're trying to get more of an idea about its utility and develop better ways to actually translate the findings from these tasks into meaningful output for teachers and for parents to implement easy supports. So one of the studies that we're currently doing is looking at the influence of family communication in particular on executive performance. So we're also looking at teacher focus groups. So we've a research project that Lisa's working on as part of her master's project, where we're going to look at teachers and get their input on task design and task reporting, so that they can actually use this information on the level and type of supports that a child needs. Because for any child with not just an executive deficit, but any type of deficit, there's always the problem of trying to find that balance. So there's being under-supported, but there's also getting too much support and not being allowed to reach those scaffolded milestones. We're developing an alternate version of the task, so a B version, in order to maintain novelty in maybe intervention studies or clinical trials. And we're also trying to further validate the task by following up children using the NEPC, which has been standardised. They have a couple of tasks for younger children, but mostly from 5-6. And we're trying to get from schools some academic data on the national test they do to compare executive performance. So the last bit I'll tap into is some findings that have just come out from another master's project that is looking specifically at family communication and executive performance. It's well established that poor SES is related to poor executive development, and we also know that poor socioeconomic status can lead to poor family functioning, which, you know, it's pretty obvious. If you have more financial difficulties, you might have to work more, there's more chaos at home because you're trying to keep everything going, so it makes sense. And Sarser had a great quote from his study where he looked at these factors. Parental responsivity, enrichment activities and family companionship mediated the association between family SES and child inhibitory control and working memory in school-aged children. So the key element there is that, yes, poor socioeconomic status has an impact on executive functioning, but we can't go to the government and say, okay, let's just give everyone more money and better jobs and so on, and everyone will have better executive functioning and get on better as a society. But we can actually develop interventions for families and go at it from that perspective, because it's something that's much more modifiable and much more obtainable. So in this study we looked at 4 to 6 year olds, and these were infant and junior classes. For the family function measure, we used Allen's measure, the score, to look at family strengths and difficulties as well as family communication. And we used a hierarchical regression analyses to look at the influence of family communication with other kind of known variables such as age, gender and socioeconomic status on executive functioning. And what we found was that family communication was associated with executive functioning more generally, but also specific subdomains were emerging like initiation, organisation and completion. So children from families of poor communication may lack that early scaffolding that's important for executive development, and that's seen as well in terms of the self-talk for 3-year-olds. There's some sort of relationship happening there. Family communication, that's a modifiable factor. That's something that can be changed in terms of an intervention perspective. And the study's ongoing. We haven't completely kind of, I suppose, tied it up quite yet. But also I just want to plug this other study that's starting. So this is part of Jen's PhD project as well. And we're going to be looking at family sleep and attention development in children under 6 years of age. So we're going to be sharing stuff on that soon, so please spread out if you can. And thanks very much. Any questions?
Thank you very much, it was very interesting. How can you be sure that your PETA score is not simply a proxy of general cognitive ability?
So we did in the first, in the utility paper that we showed, we did the Wechsler scales with all of the children that took part. So we did see that verbal ability is related to executive functioning, but general IQ wasn't. So you can have, I suppose, you can know more in terms of, I suppose, facts and things like that, but maybe not be good at organising yourself. So, for example, one good example is a student who has a really high IQ, who's maybe in final year studying for their exams, and they know a lot about the topic, but when it comes to actually reading and preparing for the particular exam questions and getting to the exam on time with their pencils and things like that, it's a little bit, there is an overlap, but it is a little bit separate.
Yeah, because I think generally people with higher IQ are better at organising themselves, but and I know the Growing Up in Australia study I was just mentioning, actually in their latest version, or with the stage 6, these are now adolescents, they're more or less treating executive function as a measure of cognitive ability, strangely, which I thought was...
Yeah, I think because it's more predictive of outcomes than IQ. So, for example, you know, ASD is one population where you often have very high IQ, but maybe poor executive ability in terms of organising yourself. So yeah, it's a difficult one to tease apart, but we always collect IQ when we're comparing between patient populations and things like that, just to kind of match on those factors.
Thanks, Michelle, that was really interesting. I was interested in your sickle cell cohort. I was wondering, are there any successful interventions for children with sickle cell to remediate the executive dysfunction?
Not yet. There's been some clinical trials that have started recently which have actually put executive functioning or processing speed, executive domains, as their primary outcome factor, which is huge in a sense because all the medics want medical factors to be the outcome. So there's that kind of avenue. There's also been some research in the US that has started to try and implement intervention studies, but the design just didn't work out. So there was one really good paper that came out recently, and it was just talking about family intervention that they tried to implement that just fell apart and didn't work. And I think it was because they were trying to do it by phone, and it was a hard to reach population, so their numbers were changing and they were moving around. So it was more so the design rather than exactly what they're trying to get at.
And so then, do you think would the best, and bearing in mind that I know very little about sickle cell, okay, so it sounds naive, I'm sorry about that, would the best solution for example, children with sickle cell, do you think the best approach is to take an executive function or primary communication approach, or is it to go through the medical route and try and alleviate the issues of oxygenation?
I think the family route, and there's a separate study that we've been working on that hasn't come out yet, but we've looked at predictors, we've looked at disease severity and environmental factors, and family function again kind of trumps all of those other factors. And disease severity variables would be things like cerebral blood flow velocity, oxygen saturation, and hospital admissions, things like that. And I think the reason for that is because if you have poor family functioning in a very chaotic environment, it's likely that the children maybe aren't showing up to all their appointments, they're not taking their medication maybe as systematically as they could be. So there's those other variables that are being affected. So if you're just trying to go at it from the disease point of view, then you're providing these opportunities for more kind of medical interventions, but they're not actually being taken up by the patient groups.
Great, thanks.
Michelle, thanks for a great talk. I'm just wondering, at a technical level, what are the kinds of challenges that you face in having artifacts and noise introduced into your ERP assessments, and what kind of strategies have you been taking to minimise that noise so you're getting good, clean data?
Oh yeah, it was awful.
It was extraordinarily, I mean, you just kind of glossed over it, but I imagine it's terribly challenging
so
when you're running a lab.
Absolutely, yeah. I mean, in terms of developing the paradigm, it was based on similar paradigms that we used for that age range, but there was still a lot of piloting that we had to do with readily available families to try and get it to a stage where it was something that they could obtain, because of course their sustained attention is poor. We can't expect them to sit there and for long periods of time. So we had to introduce different measures to make the tasks short, take breaks without taking the net off, adding in some of those extra things, and then from an actual cleaning the data on the other side, we still of course got a lot of noisy data and had to exclude a lot of data sets. I'd say at least a third of data sets were just chucked away because they didn't have enough clean trials, so they just had to be removed. In terms of...
And are you using particular software to detect clean trials, or are you doing that by eyeball?
It has to be by eyeball. So I tried...
So this is vastly labour intensive.
Super labour intensive, yeah. I tried to use some of the new kind of analyses through MATLAB, and there's a lot of issues around using kind of these techniques because they're very effective with adults, but with adult populations they're bigger, they're more consistent, and with the younger ones, what you pull out at the end often, you can't even see peaks. It just doesn't make sense. So it has to be done from an eyeball perspective, and that's something I was doing some quality control analysis for another EEG study that was collecting a large-scale database from multiple sites, and one of the issues there were that the other quality control team only worked with adults and only worked with these kind of techniques where you would code it and then they would pop out the other side, but what was popping out wasn't meaningful. It didn't tell you anything. There may have been significant differences, but you weren't seeing any differences when you actually looked at the peaks.
Michelle, I had a question. I was really liked your slide with the children playing in the schoolyard, and it made me think, well, executive function is something that evolved completely outside of academia and reading and all that. But the testing seems to be very lab-based.
Yeah.
If you develop more ecological measures of executive functioning, would you expect the socioeconomic status difference to somehow lessen? You know, it's at all?
I think with a lot of the other studies that have been done using, say, the NEPSI or some of the other validated executive measures, even looking at specific domains, you're seeing those differences emerge rather than looking at it from an ecological perspective. There's actually not that many ecological executive assessments, only because it's really like getting that paper published was, you know, there's so much kind of in terms of arguments between what is executive functioning, how do we measure it, how do you know you're measuring what you're measuring, and I think really the two need to be used in tandem so that you're seeing what are they like when they're using all these skills together, and what are they like when you actually kind of tease them apart. Because yeah, I mean, they can be performing one better in one than the other depending on what you're actually kind of capturing.
I really enjoyed it, Michelle. I was just wondering how much the self-talk in the 3-year-olds could be indicative of experience of those kinds of activities, family communication, that they were actually modelling what the adult does in their experience in that kind of domain.
I would say it's hugely reflective of how they experience things at home and how much kind of joint attention and scaffolding there is in terms of talking through tasks. And I think that's definitely in language, you know, the difference between sending out thousands of books to a whole estate of pregnant women versus actually thinking, well, they can get the free books in the library if they really want them. The issue is the reading experience and actually talking them through and making it interactive and getting them to think. So I think it's definitely 100% reflective of that. But it's trying to capture that in a convincing way is the difficulty.
Thanks, Michelle. That was really interesting. Thanks very much.
Thanks very much.